Hi everybody, this is Mr. Beckstrom, and I wanted to take a look at a couple of the problems from the homework there that I had some questions about. So here are a couple of systems of equations where we want to solve for the x's and y's in one and the x's, y's, and z's on the other. So for the first one here, we just have two equations with two unknowns. We have a line, and then we have something that's definitely not a line. Looks like it's either a circle or an ellipse or something of the sort. So when we're dealing with things that aren't either lines or polynomials, we're usually kind of stuck doing the substitution method. So we're going to solve for a variable in one equation and then substitute it into the other equation. And it looks like the easiest way to solve for a variable would be in the second equation. If I solve for the x here, I'm going to have to divide everything by 2, and that'll give me a fractional y. So I'm going to go ahead here and solve for y. If I do that, I'm going to go ahead and get y is equal to, I added 2x to both sides, so 2x plus 4. 2x plus 4. Now this is really just a matter of substituting this back into y up here and then expanding that out and solving it. So it's just now a lot of distribution in algebra. So I go back up to the first equation, give myself a lot of room here. So I have x squared plus x times, I have a y there, so I'm going to substitute in that 2x plus 4. So that's 2x plus 4. Alright. Minus, that's a y squared, so I'm going to substitute in the 2x plus 4 squared. And then that's equal to negative 5 here. Alright, so now going through here, I have x squared plus, we're going to distribute that x through, so that is 2x squared plus 4x. And then I'm going to FOIL out this 2x plus 4, so that's 2x plus 4 times 2x plus 4. I could do that off to the sides. That's a good exercise for you to do, but I've done those enough to do a binomial squared. So that's going to be minus, that's going to be 4x squared, and then the inner and outer terms, that's going to be plus 16x, because that's 8x plus 8x, and then plus 16 is equal to negative 5. Alright, so let's go ahead and I have to remember to distribute that minus, so I'll go ahead and start combining my terms. So I have alright, so I have an x squared here, I have a 2x squared there, so that's 3x squared, and I'm going to have a negative 4x squared there. So that's going to give me a negative x squared, a negative x squared term here. I have a 2x squared, oops, so that, let's get rid of that, let's get rid of that, get rid of that. I have a 4x here, and I have a minus 16x there, so that's going to end up giving me a minus 12x. X. Alright. And then I have a minus 16, but I'm going to add a 5 to that, right? So that's because I'm going to add this 5 to the other side here. So that's going to give me a minus 11 is equal to 0. If I multiply through by a negative 1, makes everything positive, make it a little bit easier. So this will factor to x plus 1 times x plus 11 is equal to 0. That's because 1 times 11 is 11, and 1 plus 11 is 12. So that means my x is equal to 1 and 11. And my y is going to be equal to, well, it depends on whether my x is 1 or 11. So I can put into this first equation here. So if I put a 1 in there, 1, so when I put a 1 in there, 1 times negative 2 is negative 2. So negative 2 plus 6 gives me a 4. So that would make this a 6. That's one of my solutions. Then if I put an 11 in here for x, 11 times negative 2 is negative 22. So in order to get a 4, I would need a 26. So 26 would be my other solution there, right? You might want to go back in, check my work, make sure that's right, make sure it works for the top as well, and that's your solution for that one. Alright, so let's go ahead and try this other one here. Solve this system. So here we have x times y is equal to z squared. We have x plus y plus z is equal to 19. And I have x squared plus y squared plus z squared is equal to 931. Alright, so this one is going to really be messy no matter how we do it. So out of all of these three equations, really the only one that we're going to be able to isolate a variable easily is this second equation here. If we, really the good choices are x and y, because if we isolate the z, then we're going to have to square that z there. So I'm probably going to choose either the x or the y, so just for lack of a better one, I'm going to go ahead and do the x here. So if I do the x, then x, put it off to the side here, x is equal to, what is that, 19 minus y minus z. So I'm going to use this in order to make an equation here. So I'm going to replace that x with 19 minus y minus z. So 19 minus y minus z times y is equal to z squared. And then distribute that out. I'm going to get 19y minus y squared minus yz. Z is equal to z squared. So now I have an equation without the x in it. Now I'm going to do the same thing with this substitution, but with this equation down here. So I'm going to replace the x here with the 19 minus y minus z squared. So that should give me, oh man, that's going to be yucky, but I don't think there's another way to do this here. So that would give me 19 minus y minus z, then we're going to have to square that, plus y squared plus z squared plus z squared is equal to 931. And then we're going to end up having to square that. So let's kind of do that off to the side here. So that is 19 minus y minus z times 19 minus y minus z. Alright, so let's just start with this one times that times that times that. So 19 times 19. Alright, so 19 squared is 361. So this is going to be 361. Alright, and then 19 times negative y, so that's minus 19y minus 19z. And then we go over here, so that's plus y squared. Y squared up minus 19y minus 19y from this one times that one, and then minus or plus yz plus yz plus yz, and then we go to this one, and that's minus 19z minus 19z plus zy plus zy and plus z squared plus z squared. Okay, so that was not very fun, was it? Alright, so let's kind of clean this up. So I've got a z squared and a y squared in there, so this is equal to z squared plus y squared. Alright, so that takes care of that one, and that takes care of that one. And I have a minus 19y here and a minus 19y there. So that's minus 38y minus 38y. Alright, get rid of those. I have a minus 19z and a minus 19z, so minus 38z. Alright, so let's get rid of those. Okay, and then I have a plus zy and a plus yz, so since multiplication is commutative, I have a plus, I'll call it yz. Alright, and then finally, we have a plus 361. Plus 361. 361. Alright, so this is, oh, this should be a 2yz, excuse me, because I have two of those. Alright, so that is all of that right there. So I'm going to replace that with that. So I'm going to have 2z squareds, right? So this is going to be, because I have one from there and one from there, so 2z squared plus 2y squared plus 2y squared. Okay, so that takes care of that and that. Alright, and those two, and then I'm going to have minus 38y minus 38y minus 38z minus 38z plus 2yz plus 2yz plus 361 plus 361 is equal to 931. Ooh, ooh. All right. So now we have this here, and we also have the other one that we made, right? We have that one right there. So now we're going to have to figure out how we're going to deal with both of those. Alright, so now what I'm going to do is I'm going to take this equation here. I'm going to kind of put it over there. So I'm going to keep that z squared on the right, but I'm going to put it over here. I'm going to take the minus y squared, I'm going to move it over to the right so it becomes positive. So plus y squared. Then I'm going to take the positive 19y, I'm going to move it over to the other side, make it negative, minus 19y. I'm going to show you why I'm doing this in a second. And then, let's see, and then I'll show you why I'm doing this in just a second. So I got the y, and do I want that too? Yes, the yz. I'm going to take that minus yz and add it to both sides, so I'm going to make it positive as well. So that's going to be plus yz, or I'm going to call it yz, so plus yz, plus yz. So bring that over to the right. So I think I brought everything over, right? So 1, 2, 3 terms, 1, 2, 3 terms. So then nothing left is over there. So that's going to be equal to 0. So I'm taking all these terms and bring them all over to that side. So this is what this looks like now. The next thing I'm going to do is I'm just going to take this and multiply this equation by 2. And I'm going to take this equation, or actually multiply it by a negative 2. So multiply this whole equation by a negative 2. So multiply everything by a negative 2, which I can, which we've been doing. And then I'm going to add it to this equation here. Okay? And before we do that, let's go ahead and just subtract that 931 from both sides. So 361 minus 931. That's going to be negative 570. So let me just negative 570 minus 570 is equal to 0. I just want to make sure everything lines up right. All right, so what I'm going to have then is I will have a negative 2z squared from this equation here minus 2y squared. I will have a plus 38y. I will have a minus 2yz. And I'll have that equals 0. So when I add these two things together, I will be, all those will cancel, those will cancel, those will cancel, those will cancel, and all I'll have left is negative 38z minus 570 is equal to 0. That's it. I probably didn't even need to do that part. And so that's my new equation, right? Negative 38z is equal to 570. So z is equal to 570 divided by negative 38. Hopefully that comes out to a decent number. Negative 570 divided by, or 570, excuse me. 570 divided by negative 38. Negative 15. Yay, we got one. Negative 15. So that means our z should be negative 15. So we got one. We got one. So that lets us know that. So now we can start going back and using that to get our other variables. So I got the first one. So now you can go back and substitute that into this one and into this one here. So that's what I want you guys to do. So substitute it into these first two equations, and then you'll have xy is equal to 225, and you'll also have x plus y minus 15 is equal to 19. That should be a much easier equation to solve for x and y. So you try that, let me know what you get, and then we'll go from there. All right. I know this was a lot of work. I appreciate you staying with me, and hopefully we'll get through this. All right. Y'all have a great rest of your week. Thanks.